We are live. Good evening, everyone. I hope everyone can see me and hear me. I think everything's working properly. We have a lot to talk about tonight. We're going to do a little bit of education on fusion energy. You know, I've been talking about this for quite some time, so it's going to be our climate change section that we're going to be touching on. And of course, we have an approaching winter storm, specifically for the northern interior, the Poconos and Catskills. We'll break down that evolution. Also, we are getting a lot of information, a lot of interesting information on the evolution of a potentially very stormy weather pattern setting up right before Christmas, right in the middle of Hanukkah holiday during, I think it would be day 6 or 7, I think somewhere around there, for Hanukkah, right around when that storm could be developing. We have Arctic air. We have a whole lot of interesting evolution taking place here. Over the past couple of days, we've had model guidance go all over the place. Yes, even the normally trustworthy European guidance yesterday tried to phase every shortwave in North America and produced a huge trough in the southwest and a giant ridge on the eastern United States, which led to a forecast where temperatures were in the 60s. I immediately threw this out because I knew it was bogus the way it was set up. But typically, there's some individuals that jumped on it, and now it is gone. And in its place is a very interesting weather pattern right before Christmas. That is for sure. And it's a good lesson, as I explained to premium members yesterday. The best way to find out if model guidance is way off, the operational guidance, is to take a look at the ensemble guidance and see whether or not there's any type of support. So if the ensemble guidance is completely opposite of the operational guidance, then you know that there is a major error. You could also study the development of convection and the evolution of the way that it forms those blocks and whether or not it meets the standards of mass physics, the basic equations in meteorology. So if they don't, then you throw it out. And so that's what we did yesterday with the European guidance, which happens sometimes. It happens with the GFS and whatnot. So we're going to go over a couple of things. And, of course, you guys put in all your questions. I'm already seeing everything firing in the community live chat on the premium section. We also are seeing some activity on the YouTube section. So it's going to be a busy night tonight as we start to move towards a busier time of year. But first, I want to start off first with a little education on fusion energy real fast. And the reason why this is really important is that one of the things I want to make sure I do on this platform is to educate the people watching. And this involves climate because it gives you an idea where our technology is going. When you look at climate research and data, there are different scenarios to look at, okay? And then based on those scenarios, you could take one of those scenarios and then create what will happen in this outcome. Scenario 8.5 is used a lot, but scenario 8.5, or called RCP 8.5, is one in which basically this advancement in technology doesn't happen and we use coal as our only energy source. If that happens, then you get rapid warming, but that's not happening in reality. So why is this such a big deal? Well, the idea with fusion energy is that it's basically creating energy of the sun, and then if you can achieve that, then you create a process where you can produce unlimited energy. Most likely this would first be used in a scenario for space travel, but you could also use it for energy concerns. You basically eliminate the need for oil, fission energy, coal, solar, all of it. You're done, okay? So what happened this week, and the reason why this is so important, and you might have seen this on the news, is that in previous experiments, you had a ton of energy going in to get to this point, but the amount of energy that was released or exited out was below or less than what you put in, which doesn't work. Because if you're putting more energy to get more energy out, then it's a useless process. But for the first time ever, we were able to reach via technology. Less energy went in and more energy went out. And so as a result, it produced a net positive for the first time ever. If you can continue to support that, then basically what you have here is unlimited energy coming out with a byproduct of 1 neutron and helium. And who doesn't like helium? I mean, it makes for great noise, great funny voices, and you can fly balloons with it. And most importantly, it doesn't pollute the atmosphere in any way, shape, or form. Doesn't warm it, doesn't cool it, doesn't do anything. It's an inert gas. So, as a result, it's the cleanest form of energy you could possibly find. And it's also unlimited. And basically, the only thing you need is basically a pool-size amount of energy to run the entire country for a full year, which is nothing compared to what we use for energy these days. So yeah, it's a big breakthrough. So I wanted to share that in terms of science because, it's a really significant move forward, and it's something that I've been talking about for quite some time, and it's exciting. So as a science nerd, I've been following this stuff since over 20 years. So it's a really exciting development. So I'm really looking forward to it. Now, let's talk about our upcoming winter storm. And the first thing I'm going to do is bring up our forecast and what we're expecting. And premium members, you know this, that we have, what we use on the premium side is a Google map so you can zoom in. On the public side, it's just a regular PNG image that you could look at with details on it. But on the Google map, you can click on your area, like if you're in Lakewood, Trenton, New York City, and get the actual forecast of what to expect. So, in this case, we're looking at maybe a trace of snow on the coastal plain, and that's going to come at the start of the storm and at the end of the storm. A little bit further inland, north and west of the I-95 corridor, looking for a trace to an inch of snow, trace to maybe a tenth of an inch of ice. This area is where I'm concerned about pretty good ice accumulation, not so much snow accumulation, all right? And this is going to be at the front dump of the storm, which we're going to go over on how that is achieved. And we're looking at 1 to 3 inches of snow, up to a quarter of an inch of ice. I would not be surprised if many locations, like around Harrisburg, Lebanon, Reading, ends up with maybe an inch of snow only at the very start of this burst, and then it transitions and shifts over to around a tenth to a quarter of an inch of freezing rain and sleet. And again, that's going to be a real concern going forward with this storm, especially tomorrow evening in these areas. A little bit further north, we're talking about Lebanon, Danville, up around 380 and heading up towards Poughkeepsie. Expecting about 3 to 6 inches of snow again at the very start of the storm, transitioning over to possibly up to a tenth of an inch of ice. This again is where we have the greatest threat for significant ice accumulation. This is snow changing to ice. Everyone here eventually goes over to rain. The only place where you remain with frozen precipitation is up here, where we have snow to maybe a sleet, freezing rain mix back over to snow, and looking at about 6 to 12 inches of snow. So how do we get to this forecast? Well, let's start off first with the observations. And the observations are pretty interesting. What would I look for first when I'm studying these observations? Well, when I'm forecasting, the one thing I really want to focus in on are the dew points. Why? Well, the drier the atmosphere out ahead of a storm like this, the more that the cold air could really hold on. Okay? So, if you have cold air sustained over the northern interior, you end up with a colder solution. And the models tend to have a difficult time handling this. even the mesoscale models. So you're seeing all sorts of different solutions on the NAM, the HRR, which we'll show in a few moments, the European. So what you have to do is you have to build on some experience here based on what we're seeing. Now I'm seeing temperatures in the 20s already, light and variable winds, high pressure and control for the most part. I'm seeing that dry air funneling down with that northerly wind, and those lower dew points get all the way down to the Philadelphia metro. So definitely plenty of cold air to work with. On our latest surface map, let's see here, weather tap might be down. Oh, there it is. Good. Let me reset that real fast. Okay, so we have our high pressure system funneling in with plenty of polar air building in, and there is our storm establishing itself with plenty of precipitation. Notice we have a lot of rainfall on the way here. There's no lack of precipitation on this. And also you can see on our upper level winds at 500 millibars, here's our ridge axis. It's going to keep us dry and cool and cold tonight, allowing our temperatures to crash. Nice 50-50 low. That's going to set up the development of our secondary low pressure system. Divergence and diffluence here supporting our severe thunderstorm threat that is evolving down over along the Gulf Coast, unfortunately. And there is our upper level low. Now note, this upper level low, let me pull out here so I can get a better look here. A lot of the model guidance for the past couple of days has been trying to phase and merge this Arctic shortwave with this upper level low. That's pretty clear that that is not happening. And so as a result, you have a better potential for a stronger secondary low pressure system, which the models are still trying to adjust to. Now, let me stress, this has already been built into my forecast. So I don't expect any changes if the surface low, secondary low ends up a little bit further east or a little bit stronger, because I'm already expecting that. I expect the models to adjust to that factor. So the fact this remains separated means that this upper level low is going to be able to continue to track towards the Great Lakes and then transition towards the coastal plain as this block slowly gives way towards basically around just to the northeast of the Canadian Maritimes. Meanwhile, we can pull up 850 millibars real fast. There is our 850 millibar jet streak. This is important because this is going to pivot and start to set up right off of the New Jersey coast, which is going to set up some pretty heavy rainfall for the coastal plain and the potential for some wind gusts over 50 miles per hour tomorrow night into early Friday morning. So those are all the observations for this storm. Oh, by the way, the water vapor satellite picture is incredibly impressive. Nice upper level low. See this dry air here? If you want to know whether or not we're having strong lifting with this storm, you see this signature right here? This is a byproduct of that. This is rapidly rising air here, rapidly sinking air here. So when you see this, what you're seeing here is a strong circulation in the atmosphere of rapidly rising air and then crashing air. And as that evolution continues, you start to get the support for more and more cyclogenesis right around this triple point right here. That triple point is shifting towards the mid-Atlantic coast. Therefore, another supporting observation for secondary low pressure development. So what I'm trying to walk you through is, don't just look at the models and say, well, the GFS is doing this, the European is doing that. Look at the observations, look at the evolution that's right in front of you, and understand what that evolution means and what influence that has in your forecast and how to make those adjustments. So when you're creating this forecast, what you don't want to do is try to chase the models. Okay, it's the meteorological version of chasing the dragon. Okay, it's not good at all. Okay, because what happens is that you keep on changing your forecast with every model guidance that comes out. When you could tell when someone's doing that because they start to focus too much on 18Z and then 12Z and then 0Z and then, well, I gotta make this adjustment and now I have to make that adjustment. And if you have a plan for your forecast and you understand the general factors involved in it, you don't need to make a lot of changes in your forecast then. The key to being a good meteorologist is to recognize the fact that you'll never be perfect. And trying to be perfect is the Achilles heel in every meteorologist, because it's kind of like an ego thing. So when you have all these observations in front of you, don't try to be perfect, because you'll never be perfect, but try to be really good and give your clients or the general public the overview of what to expect and the ballpark idea. So now, there was a time a couple of years ago when people tried to do 2-inch snowfall parameters, and I'm like, that isn't for me, because I'm not that good. And if anyone's that good constantly, they'll probably get kidnapped by the government, because they're like a cyborg or something. It's just rare. It's nearly impossible to pull off. So here's our model guidance. This is the European guidance showing the evolution of this storm. What you want to do is combine several factors here when you're using the model guidance. You're using the models like the GFS, European and Canadian. Those are your synoptic scale models. And with those, what you want to do when you're looking at this type of scenario is that you want to pull up and look at synoptic scale features. So you want to look at the jet streak here. So around tomorrow night, let's say between 11 p.m. and midnight, you have, and 11 p.m. and 1 a.m. Friday, you have this strong jet streak here. Now, this jet streak, 850 millibars, what does this produce? Well, first of all, it's drawing a ton of moisture in from the Atlantic. It's enhancing lifting as this jet streak acts kind of like a fire hose marching up the Jersey Shore and heading towards New York City. It also allows for mixing of the atmosphere down to the surface of strong wind gusts. And it also enhances the transport of warm air and drives your rain-snow line inland. So if you're seeing support and model guidance of very heavy snow over, let's say, northwest New Jersey, the Hudson River Valley, let's say southeastern Pennsylvania, that model guidance is going to have a difficult time pulling that off, because all the synoptic scale models have this signature. And what this signature will do is drive your rain-snow line, or snow, sleet, and rain line, back to the northwest. So that's why in the forecast, we'll go back here, that's why in the forecast here, this is where I keep all the snow steady, and everywhere else, this is where I keep the precipitation pretty much all snow, and everywhere else, you pretty much have a mix over to rain eventually. And the difference in the snowfall totals is basically the timing of that changeover to rain. And that's all based on just looking at this one signature here. Now, the other feature you want to take a look at is the lifting involved here. And what you can do, you can look at 500 millibars and you clearly see plenty of divergence and diffluence on the east side of this upper level low. The primary low is still back to the west here. But take a look at the 850 millibar low during this time period. And pull up here. Okay, so what this will tell me is that this setup allows for the cold air to stay locked in over the Poconos and Catskills, because the warm air transport will start to come to an end as this 850 millibar low takes over. And so you can see that very clearly as we get to Friday morning and then Friday afternoon. And that shows up really nicely here with the cold air transport. So these factors here are how you start to put together this forecast. And then we have, let's see here, the various model guidance that you can look at in terms of the mesoscale data. So this is the high-res European guidance. We have the NAM model guidance, which does show cold air, but it really warms up on the NAM. But when I took a look at the surface temperatures, they were colder than what this depiction would suggest. So I think that the NAM solution in terms of precipitation type might be a little bit too warm, and then it tries to overcorrect. And then the HRR guidance, which I think does a reasonable job in this solution based on what we're seeing here. And so that is how I developed this forecast. And I'll take your questions on the forecast as soon as I get done with everything else. Finally, let's talk about after this storm. After this storm, we start to shift towards our real impressive potential winter pattern here. You get your upper level low. This upper level low in this storm that's marching through, it basically locks in the death of the southeast ridge. That's what this storm is all about. This storm, remember, well before this storm started to develop, we had to keep on fighting with this southeast ridge. This storm essentially annihilates it and just rips it apart. So you have to get a storm like this in order to get to that point. And so as we study our next storm setting up around the 23rd to the 25th, there are some very interesting similarities I'm seeing in all the model guidance. On the European, and I'm going to show you the same signature on the GFS, Canadian, and other guidance, I am seeing a very strong signature of rapidly falling 500 millibar heights. Now, you could say initially that this is probably overdone, and hey, it's a reasonable statement to say. Like, hey, this looks like it's overdone, but I'm seeing the same thing showing up on the GFS ensembles, the European ensembles. If you want to pull up the Canadian, they're all showing the same thing. Why is this signature really important? When you have 500 millibar heights spread like this and crashing, this is a very strong signal for a Miller B type storm. That's a type of storm where you get a low pressure system in the Tennessee or Ohio River valleys that redevelops towards the mid-Atlantic coast, somewhere between North Carolina and the southern New Jersey coast. How fast that evolution takes place, that jump to the coast, where and at what rate the low pressure system intensifies, basically gives you all the details for the storm. So at this time, we are way too far out to go into details about who gets what snow, where's the rain snow line, how fast does the storm move, all that stuff. It's an unknown. But what I could tell you tonight is that it's one thing to have one model to kind of pick it up. But when you have multiple models showing this potential and showing this type of Arctic air running into the coastal plain like this, that is a huge storm signal, very huge storm signal. And the reason why that really caught my eye, if I can find, here it is. This is the setup that really caught my attention. Now here we are with this warm air surging in, right? And it looks like a pretty warm storm, right? Then you get this cold air transport. You're getting a drop from the 40s into the single digits. That's pretty impressive. And when you have that type of thermal gradient in play here, it creates a lot of model mayhem. So the first thing I'm going to tell you with this storm is you're likely to see multiple different insanely over-amplified solutions over the next couple of days. Don't get overexcited. Just recognize the fact there's a storm potential and be prepared for it. That's pretty much all I can tell you at this point. But this type of thermal gradient setup here really allows for rapid intensification and bombogenesis. And in terms of the storm itself, let's see here. I had one good depiction here of all the low pressure systems. Oh, hold it. This one right here. Okay. So we have the GFS solution from 18Z. Storm off the coast, possibly inverted trough. There's our European setup. And then we have the Canadian setup. So same Miller B type scenario, just different ways of dealing with the transfer of energy. The GFS setup and the European setup. So basically they all are illustrating the same potential, but we don't know the details yet. But there's a lot of interesting support here. And then beyond this point, there's further support for additional storms, a feedback process, and sustained cold air going right into January. So a very interesting pattern to say the least. So now it's time to answer all your questions. And the boards here have been pretty active here. We got plenty of questions here on YouTube. We got plenty of questions on the live chat and the premium live chat. So of course, YouTube, I'll come back to you and answer the best questions. And of course, we have our live chat. So let's go back here and start way back here. Does this storm have good potential for Cleveland area because I might travel at that time frame? Which storm? We had 2 storms. Get back to me, Joshua, on which storm you're talking about. Should be a good one tonight. Thank you. Good evening, Carr. Good evening, Chris. Looking at Earth News School, while the 10 millibar polar vortex has much stronger winds, it is very warped and a massive feed to the poles coming from the tropics all the way down to the equator, with a little cross equatorial flow through South America. 70 millibars looks like northern hemisphere vortex, not just the pole. Okay, so here's something that I wanted to, this is a great question because I wanted to touch on this one thing with the stratosphere that I've been seeing a lot on in social media. This is 10 millibars. This is a relatively strong polar vortex, okay? It is not a good idea to focus in on the 10 millibar polar vortex in this winter. And the reason why is because of the unique situation that we talked about with the influence on the volcano. Remember, all of the water vapor buildup that we had in the southern hemisphere and how that's influencing the high latitude blocking that we're seeing was focused from 50 millibars to 70 millibars. It had literally no impact from 30 millibars on up. So what does that mean? It means that we're basically dealing with 2 separate environments from 30 millibars on up into the mesosphere and below 30 millibars. So what happens at 10 millibars right now doesn't have a significant impact on our weather pattern. If it did, we wouldn't be having any of this high latitude blocking. You wouldn't have a negative NAO, negative EPO, any of that. Because this would have suggested that you have a strong polar vortex from 10 millibars all the way down into the troposphere, which would have led to a very mild weather pattern. But when we go to 70 millibars, you can see that is not the case. The polar vortex is very weak, it's distorted, it's almost split, it keeps on splitting and getting torn apart. So we're clearly dealing with 2 different environments. So when you see on social media someone bringing up the winds at 10 millibars being very strong, you have to understand that that impact on us this year, and only this year I can really say this, doesn't matter at all in any way, shape, or form. If this was any other year, if we were talking about last year and we saw that signature, it'd be a mild winter and I'll be sitting back saying, sorry guys, not much going on. All the cold air's trapped up in Canada. But in this scenario, that's simply not the case. All right, let's see our next question. Your operational earlier in the week didn't even match the observations. Yeah, here's what happened with the Euro. I did some investigation on it. It got some bad data in the Pacific. And this is how sensitive these models are. A little bit of bad data in the Pacific caused too much convective feedback, and that led to a cascading effect in which then one of the short waves was too strong. It got ingested into the polar vortex. The polar vortex expanded, swallowed up everything in North America, and produced that insane mild solution for us. I have a general rule. Whenever you have a model that tries to phase every short wave in the northern hemisphere into one huge vortex, unless you're working for the Sci-Fi Channel, that's not going to happen, okay? So that's when you just take it and throw it out and move on. If you want a space program that can reach other planets and ultimately other solar systems, future energy is a must. I would strongly agree. Absolutely. Steve, got to disagree on oil, even not used to provide energy to byproducts of refinery. Go to virtually every product made today. Without a workable solution, oil still needs to be refined. Yeah. I have no problem with that point. That's a fair point. My focus is strictly on energy. But again, I also believe in technology. I guess you call me a technologist or something. Where I believe that we will find solutions to those questions. But you're absolutely right. Everything from your computer to your vegan chips are all because we use oil. So, I mean, that's a fact. That's fine. And there's nothing wrong with admitting that fact, because you have to admit reality in order to solve problems. My point is that with fusion energy, you could at least take the energy equation that is a major problem, not just for the United States, but the whole world, and you solve that very, very easily. And it's just a huge breakthrough for humankind. I'm telling you right now, you're not gonna remember this day, but it's gonna be in the history books. 18Z GFS Ensembles continues the trend of an impressive winter storm signal from December 22nd to 24th. Agreed. Your ensembles were very impressive as well. Yeah, definitely. And this won't be the last one either. Typically what happens with these patterns, especially when you get a strong negative EPO signal, is that you get one storm and the models have a hard time handling it. But once that storm moves through, it sets up the feedback, and the model guidance, the operational model guidance, is able to see that pattern better. So until you get past that point where you establish the initial storm environment, you're going to get a whole bunch of crazy solutions, right? So that's why I did not get concerned when some models were going warm for the end of the month. Other models then went historically cold and back and forth, because that's the nature of the model guidance in this type of atmospheric environment. But I will say that once we get that first storm locked in, do not be surprised if we get very busy thereafter. Got Indy out there, was taking the garbage out, and you can hear the wind. Oh, got windy. Yeah, absolutely. Needless to say, have to be out tomorrow evening. Do you expect any ice around Essex Passaic border tomorrow evening? Not significant, I don't think, but definitely use caution, drive slower. Even without significant icing, there's going to be some slick spots, and then you're going to be dealing with very heavy rainfall and strong winds. So use caution, drive slowly. FYI, seeing Mars so big in the sky this past week or so has been really neat. Yeah, agreed. It's been pretty cool. Any flooding and flash flooding concerns with this week's storm? I don't think there's going to be a lot in terms of coastal flooding. There's going to be some urban flooding with the heavy rainfall tomorrow night into Friday morning. But I think that's about it. I know the models are in the windshield wiper effect for Christmas Eve storm. What, in your opinion, is the max potential for that storm KU worthy? If that Arctic air is a reality and you get it to crash towards the Gulf Stream and that 50-50 low is locked in, like what the European ensembles are showing, this has the potential to be a very impressive storm. Now, whether that means snow for your backyard, I don't know. but there's a lot of potential. Never underestimate the potential for Arctic air to create a whole lot of mischief. Okay? And that signal keeps on showing up, and it's something to really watch out for. Let's see. We've had a lot of days this month where temperatures colder than normal, with some days and nights feeling more like January than December. Is this a direct result of the stratospheric warming up near the North Pole, causing the polar vortex to split? If so, is this something that has always occurred, or is it something that happened more frequently because of climate change? It's one of the factors. I think what we're seeing here is a combination of different things. You're seeing the weakening of La Nina that's taking place, which we could see very clearly in a lot of our data here, with a steady, slow weakening. Still an east-based La Nina, but clearly a weakening process. You're seeing, as a result of the thermal gradient here in the Pacific, support for a pretty impressive negative EPO pattern, which is something that we've been talking about in the winter forecast. And the combination of those factors is helping to disrupt the polar vortex. So that disruption is allowing for that cold air to come southward. So to answer your question, it's a combination of factors. Is this an impact of climate change? No. This is something that happens regardless of our influence or not. And the stratospheric influences is something that will evolve regardless of our influences on the Earth's climate. One thing that would be different is if you want to consider, and we can't really say this without research and looking back on this pattern a couple of months from now, is if you try to make a connection between the warmer waters in the Arctic and the lack of sea ice to further enhancement of that disruption, then you could fold that back into climate change. But we don't have the data to support that claim, so I'm not going to make that claim until we have the data to support that type of suggestion. But I would call this a combination of factors. Is it possible the NAM is slipping a warm layer someplace above the surface, like at 9 to 25 millibars or thereabouts? I have been seeing guidance where that is the case. The problem is that it looks a little bit too aggressive compared to other guidance I've been looking at. It could be right. That would definitely basically lead to the low part of my forecast range. But based on what I'm seeing with the evolution of the storm itself, I think that the NAM is being a little bit too aggressive at 850 millibars and 925 millibars. And I like the evolution shown on the HRR in that process. And so that's where I've kind of met that blend. Will it become easier for the models to pick up on what the storm next week may do once the first storm is passed and the impact of the 500 millibar pattern is known? I don't think so, because of the nature of the storm development. Miller Bs are notorious for having difficult times with models. I probably said that wrong. What I mean by that is that the process of a Miller B storm is such that you have so much specific evolutional timing with that storm that any one thing that's off is going to create a completely different solution. So we might get a better idea on the overall environment, but the details will still remain fuzzy until probably maybe 6 hours out. The storm for next week for Cleveland. The storm for next... you know what? I would watch out for lake effect snow. That's what I would watch out for. Because you got that Arctic air coming in, and you got very warm lakes off of Lake Ontario, Erie, even around Lake Superior, all the Great Lakes. Heck, I'll just name all of them. And you got that Arctic air come in. Yeah, you'll get a byproduct from the storm, but watch out for that lake effect snowfall. That might be real shocking. What's the start time for New York City tomorrow? Good question. Let's pull that up. Let's see. I think somewhere around 4 o'clock. There I have it. Yeah, about 4 to sometime between 3 and 4 o'clock we should start to see rain. I wouldn't be surprised if we get a little bit of snow at the very, very start of this for like 2 minutes. Don't blink. Is the current pattern still looking similar to 95-96? A lot of different signals showing up that are similar. But again, in order to reach 95-96 levels, what you need is verification of a locked-in negative NAO block and then storm after storm tracking under that block. We're not there yet. Miller bees usually have a sharp cutoff, right? Absolutely. And then they can also create a lot of havoc in terms of slowing down and creating some issues. Will this winter have mostly Miller bees? No, I think it's going to be a mix this year. Okay, so let's check out YouTube. We have holy smokes, we have a ton of questions out here. Of course, let's see here. Will there be a mix to start of rain and snow, then change to rain at the coast? Would not be surprised if we start off with a little bit of snow and sleet, but again, don't blink because you'll miss it. Rapidly changing over to rain. I don't really see this as a significant snow or ice event for the I-95 corridor or any of the major metro areas. Let's see here. Wow. Where's the snow along the I-95 corridor? All I kept hearing all month was about these big snowstorms. It's always rain. I wanted to answer this because, first of all, I don't know how many times I put out on social media, on here, on Twitter, Facebook, my own website, there is less than a 10% chance of a white Christmas on the I-95 corridor. Do you guys understand what that means? That means the idea of having perpetual major winter storms in December is very hard to pull off. And I said that repeatedly. I never said that the I-95 corridor all December we're going to get all winter storms. I said that the pattern coming up for the end of December, right around the holiday season, is probably the best we've seen in a decade, which is absolutely true. I mean, it is. How many times have we seen over the past 10 years waiting for the polar vortex to weaken, waiting for Arctic air to get anywhere near us, waiting for our first flurry, stuff like that? We're already past those points. So, yeah, this pattern is the best pattern I've seen in 10 years. But I don't know about other people, but I can only speak for me. Where's the snow? It's coming. I am very confident of that. But you have to understand the season. You have to understand what we're dealing with here. It would be extremely unusual to have multiple winter storms in early to mid-December. And I've said repeatedly, after December 15th is when I would start to look for that first snowfall on the coastal plain. And last I checked, it is December 14th. So starting tomorrow, we can start to look. And hey, look, we're talking about a winter storm already. So there we go. Let's see here. I live in Huntington County. Let's see here. How would the storm setup affect the overall pattern, including the trough NAO high latitude blocking? This current storm sets up basically what this current storm does. Here, let me pull this up here and pull up 500 millibars here. What this storm does is eliminate the southeast ridge. And the elimination of the southeast ridge opens up a whole bunch of potential with this high latitude blocking regime. So that's why this storm is so important, as it is the storm that I've been waiting for and I've been calling for quite some time for the start of mid-December to kickstart the end of the southeast ridge and the support for your 50-50 low, 50 north, 50 west, upper level low blocking setup. December 10th produced a blizzard and the PNA was negative. We don't need a PNA to be positive. Yes and no. The storm in 2010 started out with a positive PNA and then went negative as the storm evolved. You need the initial ridge axis around Montana and Idaho, so that way you had the correct wavelength in order to support East Coast cyclogenesis and the perfect storm track to support snowfall on the coastal plain. Let's see here. I'm just going through all the questions. See, nothing's not as strong as first thought. Cold air, pattern change, blocking, etc. is what I keep hearing all month long. Yeah, and that's exactly what's happening. I don't know. Justice, I don't know what to tell you, man. I've been pretty much straightforward exactly how this pattern is going to evolve. If you heard stuff about constant winter storms starting December 1st, you didn't hear it from me. Let's see here. Weather apps, I won't get involved in that. Let's see here. Well, there's a heck of a debate going on when winter starts. Do you think freezing temperatures will penetrate Texas? Yes. Looks like... Yeah, I definitely think that with this Arctic blast, especially northern Texas, January to March is when I-95, of course, sees the potential for snow. I would say, yeah, that time period is usually where you see most. Actually, a study was done. The majority of major winter storms on the east for the I-95 corridor typically is found from December 28th through February 15th. That's where the majority of your storms are, Then you start getting your outliers for the end of February and March, and then even less so for early December through October. So it's kind of like the chart is kind of like a very slight incline in October, November, early December, and then a huge spike once we get past mid-December, and that continues on through January into early February, and then a slow decline in mid-February through March. Is the GFS model still discounting after the upgrade a few months ago? Oh, this is a good question on the GFS. Okay, so GFS went with another upgrade a couple of weeks ago, and ever since then it's been having some issues, especially with convective feedback error in the tropical Pacific. So I've been very hesitant to rely on that guidance for a basis for the forecast. I think it's starting to make some adjustments, so we'll see if it improves or not. But statistically speaking, the European and the Canadian has been kicking the GFS butt in terms of verification. Let's see here. Back to the premium chat. Oh boy, we still have a lot of questions. It's a busy night, guys. Excellent questions. We haven't had a genuine Alberta clipper in a while, at least a couple of years, which itself seems really unusual for a stretch that have been mostly east-based La Nina. I think we'll see more of them, but you're right. We haven't seen a lot of Alberta clippers, but I would not be surprised if we see more of those setting up for late December and January. We'll see whether I'm right or not. But the reason why I say that is because the polar jet stream is going to be pretty active. I think we're going to have short waves diving in. Don't be surprised if we have an Alberta clipper diving towards a short wave in the subtropical jet stream, and that interacts and transitions into a Miller B storm. I think that's going to be a theme that we're going to have to watch out for, especially in early January. A lot of those snow on Christmas years in the I-95 corridor probably came before the urban heat-on effect. actually is kind of dispersed pretty nicely. You would think that there would be a significant reduction, but really there hasn't. The primary factor as to why we don't see a lot of snowfall around Christmas, even before we establish our urban heat island effect, which does have some impact, is more due to the sea surface temperatures around the area this time of year than anything else. Those warm sea surface temperatures make it more difficult, if you get any type of easterly component, to keep temperatures below freezing. As you get into January, that factor significantly decreases, and so therefore, with a northeasterly wind, you can get a pretty good snowfall. But as you all know, easterly winds is death for snowfall forecasts. So there's a reason why. It's because the air is coming right off the Atlantic Ocean. Blame all Christmas movies for people expecting snow every Christmas. You know, here's the thing. All those movies, if you ever notice where they're located at, they're always located in Iowa or the upper Midwest, which makes sense. You know, or Vermont. Yeah, Vermont. Yeah. You know, New York City, it's hard to pull off. It really is. Even the Macy's Day was a Miracle on 34th Street. That didn't have a lot of snow with it. At least not that I remember. Steve, looks like next week's storm is late Thursday into Friday. When would you expect the operational guys to start handling on the eventual storm? That's a good question. I probably wouldn't lock in on any details until probably this time next week. Probably in our next live chat, when we're talking, is going to be a pretty busy one, I think, where we're going to be able to actually break down some details. Is it possible for the storm track to be suppressed to our south if the block is too strong? Yeah, if a block is too strong, it could definitely suppress the storm, but I haven't seen any data to support that type of output. It's looking like late Thursday, potential storm. When do you... okay, I already answered that. How long do you think the snow season will be? That's a great question. Okay. My concern for late winter, mid-February to March, is that I'm not sure exactly how ENSO plays out. What I mean by that is that I have a strong idea that La Nina will be collapsed by February and March. Okay, it's been the going forecast. What I'm not confident in yet is what the MJO will do as a result. So I think that there is support for us to continue to have, let's say, a chilly start to spring and some winter storms until March 15th. But that is strongly dependent on whether or not the MJO ends up in phases 7, 8, and 1. Or if it ends up in phases 3, 4, and 5, that would be a warm start to spring. So I'm not sure yet on that. I'm just being honest. I have no idea. And typically the MJO forecast, you really don't want to rely on that beyond 7 days, if not 10. So that factor is something that I am not sure about. Let's see here. Except for that one winter where we get ice storms with southerly and southeasterly winds right into New York City Metro. Yeah, it was a freaky year. What happens after January 7th? I'm thinking we'll probably, and this isn't something that's locked in, but here's basically what I was thinking with the winter anyway, which the winter forecast is already issued, so we already went through it. We'll probably see a reload sometime between 7th and 12th. So like a mild weather pattern, more like a zonal pattern. Okay, as the whole pattern resets and reloads. And then after that, after the 12th, then we fall right back into this active and cold weather pattern. I see there being a reload and thaw. I don't know of any winter day where you don't, to to be honest with you. But I see that happening sometime around mid-January, sometime around the 10th, and then we fall back in. But I don't know the details of that just yet. How cold do you think it will get here starting the end of next week? I would not be surprised if we're stuck in the 20s around Christmas. Put it that way. For highs. Not lows, highs. I thought you had mentioned the MJO will not have much of a factor this winter. It won't, at least for January and much of February. But when you eliminate the La Nina influence, i.e., your SOI values basically trend towards neutral, then there has to be a forcing parameter that takes its place. And so by the time you get to late February and March, that's when you'll start to see more of an influence from the MJO. The MJO, I think, is going to be more of a factor for spring, how spring starts and whatnot. So that's why you have to consider it. If you're going to eliminate one forcing parameter in the tropics, then another one has to take its place. And that other one would be the MJO factor, which, like I said, it's difficult to forecast that 7 days out, let alone months out. So that's why there'd be a very unusual setup. 20s with a fresh snowpack. Well, it's possible. It's possible. Let's see here. Wow, and YouTube is active as always. Let's see what we got here. Clipper scenario was back in the winter of 83. I know it's an operational run on a day 9 European, but a 504 decameter low in the Ohio River Valley has to be pretty rare, right? Yeah, that's kind of what caught my attention. I'm like, holy smokes. Now, most likely, the operational is way over amplified. If that verifies, then not only are we dealing with an impressive storm, but we're dealing with one heck of an impressive Arctic air mass. Probably one of the coldest Christmases we've seen in a very long time. Or if you're celebrating Hanukkah's as well. It's going to be cold around the holidays. And by the way, with that type of air mass in place, all you guys going out to New Year's Eve and standing out in Times Square for hours on end, if you could keep that, I'm going to stay home with my little hot dogs. I'm not messing with that. Forget that. Let's see here. Being neutral right now, what does that cause? Okay, that's a good question. The MJO being neutral. A lot of the MJO this winter, and let me pull that up here. There you go. For the most part, our MJO has been in a neutral state. Now, the reason why the MJO has pretty much been in a neutral state is because the stronger tropical influence is La Nina. So here's basically how you play out tropical forcing. And this is, again, very, very basic overview. Right? There's more details than what I'm sharing, but here's the basic idea. You could have La Nina influences, El Nino influences, or if neither one's in effect, then the MJO becomes a stronger influence. When El Nino and La Nina is in place, the MJO kind of acts like a bellwether and signal. Okay, it gives you an idea of the potential for storms and pattern configurations within that La Nina and El Nino influence. So it's kind of like a nesting doll in a way, right? Where your overall theme is a La Nina or El Nino. Then you have to consider what is the strength of those two features. Then you have to consider the orientation of those two features. Then after you do all that, you go back to the MJO and you look at where it's moving, whether or not whether it's even influencing the weather pattern, and if so, what phase is it in, and how does that correspond back to the El Nino or La Nina influence. So they kind of play off each other. But El Nino and La Nina are always going to be the dominant influence. When those disappear, that is when the MJO is the dominant influence on the tropical forcing. We didn't even get into other type of forcing parameters like mountain torque, stratospheric influences and stuff like that. What do you think of the chance of storm track being snow for? I'm not going to answer any. Okay, I'm just going to put it to you this way. For the storm next week, there is no way I'm giving any answers about what to expect as far as snow, sleet, or rain for your backyard or your neighborhood or your city. I'm not touching that with a 10-foot pole because no matter what I say, it's going to probably end up being wrong. So I'm not touching it. No way.
It's 9 o'clock.
It is already? Wow. Any ice concerns for central New Jersey? No. And let me go back to the community chat. Let's see here. Will snow cover from this storm in Pennsylvania and New York help to enhance the cold air in the next storm? That, again, is a great question. I'm not sure yet, but it's certainly a factor that I'm studying. And that could influence the ability for the low pressure system to transfer towards the coast faster and also help to drive a faster fall into 500 millibar heights, but that is a factor I am not sure about just at this time. And as my wife pointed out, and my voice is starting to give out, it is 9 o'clock, and this has been a great live chat. I want to thank everyone for joining. It has been a blast, and I hope that you guys learned a lot too with this live chat. We talked about fusion. We talked about our winter storm coming up. We're talking about the next winter storm and the pattern overall. So next week might be real interesting. I think I might wear a Santa hat. What do you think? You think I should wear a Santa hat, huh? I got one. There you go. Maybe I'll do that. So I will see you guys next week at 9 o'clock. I mean, should I say 8 o'clock? I'm losing my mind. There we go. At 8 o'clock next week.
You need sleep.
Where I will need some sleep. There we go. So have a wonderful night. And as always, let's see here. Where's this thing? There it is. Stay safe out there.